the first portion of the solution for worksheet 10b, we deal with the box beam, which is a rectangular cross section, and we know what is the tau at neutral axis and tau b at point B, and also the distribution of the tau, which is the transverse shear stress. And with that, we already know the centroid for the rectangular cross section. Now move to the T-beam. And at the T, it's not symmetrical in this case. It's symmetrical in about y-axis, but not the x-axis. We need to find out the centroid first before we can locate the neutral axis. And we done that in the previous lesson in the area moment of inertia. So let's talk about the T-beam, and for simplicity I copy the T cross section the same here so that we don't have to go back and forth on the previous page. So the first, again, we want to find out what is the tau at neutral axis, and also the tau at point B given in there. And again, the equation the same, tau equal to VQ over IT. We need to find out, V already given, find out Q, I, and T. And V given in this case, just write down 50 kips, and in this case given. We need to find out the centroid before we locate the neutral axis, and I can tell you, right? And we need also to find out the I, and I also need to find out the centroid to find out I. So we make a table. Like I say, if you're not sure, go back to lesson 4 and 5, when before the buckling, we learn how to make a table to find out the area moment of inertia. So let's find out the centroid and I. Okay, so find centroid. Why find centroid? To basically to locate the neutral axis, right? And then I, area moment of inertia. So what is the column we need to make in the table? The first one, we have shape, and then we have the A areas, we have Y, okay, Y bar, and then we have A, I, Y bar I, Y bar A, and then we have I for each standard shape, and then we have the distance to apply the from the centroid to the centroid of each individual shape. And the last column, it will be I plus A for the parallel axis theorem, dy square. Very important. And this go with you again later on in this class. So be very careful when we learn and find out how to determine the area moment of inertia and the centroid. So to find out the centroid, we have two shapes. Break it down, that cross section into standard shape, That very simple, and we even do that in statics. Two standard shape, as you can see there. So the shape, we have the two rectangles. So let's draw down here in the shape. The first one, and both are positive, as you can see there. Positive, that one, positive here. And then we have the vertical with the rectangle shape there, and also positive. Let's put the dimension on. We have the first shape is 2 inches, and that one you have 2 plus 2 plus 2, so you also have that here, 6 inches there. The vertical one portion, it equal to, so basically this is the portion I'm talking about, and that one for that equal to 6 for the vertical, and the thickness, basically the width, so 2 inches. So we have two shapes. So go ahead to find out the areas, area rectangle, so it is 12 unity inch square. This also 12, the same. Let's define the y bar. Let's define that from the bottom, just something we did before, right? From the bottom of the cross section. So y bar for the first shape is from this bottom to here, right? So it will be equal to 6 plus 1, because that is 2 for the thickness of the flange, so that equal to 7. The y bar for the next is from the bottom to the centroid of the whole of this shape here, and that, as you can see, the height is 6 for rectangle to that centroid of that individual shape. It will be 3, so we can plug that in 3 in here, inches, 3 inches. Y bar A, so just time them, 12 times 7, so we will get that equal to, let's put another color, so here we have 84. 12 times 3, 36. And I, for that shape, as you can see, I equal to what? BH cubed over 12. So it will be, for the I here, it equal to, if you want to write out, so it will be 2 cube times 6 over 12, right? So, okay, can draw very small in here. So it will be 6 times 2 cube over 12. So the I equal to 4. The next one, for I equal to, just reverse, 2 times 6 cube over 12, so that it equal to 36. Okay, so that, so far we can do it, but dy we cannot find out yet. So let me put that a table so that we can easy to see. We need to find dy, and we need to fill that out for this table. Okay, find out y bar. Let's find out y bar first. To sum up all the areas, here, areas, 12 plus 12, 24 inch square. Sum up all that column there. So sum up all the y bar A here, 84 plus 36, 120 units inch cube. So from that we can have y bar equal to sum of all the y times I divided by sum of all A. So 120 divided by 24 equal to 5 inch. So when that 5 inch, we know now the y bar for the whole cross section. Now we can write out here y bar from whole cross section to the centroids located of the whole cross section is here. That's a y bar equal to 5 inches, as you can see, and the neutral axis actually go through that centroid, and that is neutral axis, as you already know. Go to the centroid by definition previously. So you have y bar, and now go ahead to complete the table, which is find out dy, which is the distance from the neutral axis from the centroid of the shape on the left to the neutral axis or to the centroid of the whole cross section. So the first dy, it will be, look at the one I put on the left here. It will be from this point, the centroid of the standard shape on the left, as you can see, to the point, to the neutral axis of the whole cross section. And with that, as you can see, it will be equal to the bottom is 5. So the top here, you can see that distance, of course, it will be equal to the whole thing is 8, that 5. So this is 3 inches, as everyone see. So the distance from the red dot to the blue dot, that is dy for the first shape from the neutral axis to the centroid of that standard shape. So it will be equal to 2, as you can see there. So it will be 2 inches. And the next is the dy for the shape in the web. So from the, also from the neutral axis, the red dot to, let me put another color, let's put black dot there, to the neutral axis to the centroid of the that shape. So let's put the blue here. So that actually the dot we have. So from the red to the green one for this shape. So as you can see, it will be equal to 5, and this from here to there is 3. And we do it earlier, so that difference it will be 2, also 2. So 5 minus 3 equal 2. So now we just go ahead to complete with I plus a dy square. We already have all of that. It will be equal to 52 and inch power 4, and that one is equal to I 36 plus a 12 times 2 square. So we will have that 84. So from that we can have I the sum of all of that here, 52 plus 84 equal to 136 in power 4, and that actually the I we are looking at, area moment of inertia 136 in 4. So that, as you can see, takes some time to find out the centroid and find out the area moment of inertia. So let's stop here and move on to the next part to really touch the question asked. What is the tau at neutral axis? What is the tau at point B? And then distribution of the transverse shear stress throughout the cross section.